Okay, good morning, all of you. So, as I already shared this, am I audible? Hello. Hope I'm audible. Hello, hello. Ayush, can you
Yes,
hear
sir,
me?
you're audible.
Okay, done. Uh, okay, this is like, okay, not like assignment. Okay, I just want to know, okay, everybody can able to solve this. So let us not spend time in okay, getting the answers for this one. So this is straightforward. So you may have to use appropriate equation for T on, T off, and then find the frequency. And once you know what is T on, T off, you can find the duty cycle. Am I correct? Hello. One of you can
Yes, sir.
unmute yourself. Okay, Ayush, you can be with me. Of course, since we have a Vxn voltage, we need to use that appropriate expression. Can somebody spell out what is the expression for T on over here? T on is equal
The
to,
first question.
yeah, the first question. Uh, is my camera content visible? Hello.
Yes, sir.
Okay. Is the expression for this T on time is equal to RA plus RB into CT ln of what is this ln of? Is it VCC minus what is this? Is it VTL by VCC minus
Yes,
VTH?
VTL. This is minus
Correct.
VTH.
So actually VTL is what? Okay, what is VTH? What is VTH? It is
The
actually V
VTH
external.
is V external,
Okay, VTL is exactly half of VTH.
half
Done?
of V external.
Okay, if you know these
Yes, sir.
these equations, you can know what is T on. So what is T off?
The
Irrespective
T
of the
of
value of
R2
V
CT.
external, it is always 0.693 RB into CT.
CT.
This is the
CT.
equation when switch is off. Because I have written, okay, switch open and switch
Yes,
closed. When the switch is open, this is when S is open. Correct? When this switch is open,
yes, sir.
the charging will going to happen through RA as well as RB. That's why you have RA plus RB. If I close the switch, what is the modification of the equation?
So it will be RA plus 100 ohm.
RA plus 100 ohm or RA plus RF. So this is very crucial. Of course, how about
Yes, sir.
T off? How about T off?
T off. It will be same.
It will be the same. So T off remains
Because
same
all,
for any
yes,
frequency, any condition of your switch. Sorry, in not any frequency, any external voltage and any position of the switch. T off remains the same, whereas T on will change. T on will change. This RB will be replaced by the forward resistance of the diode, and of course this VTL VTH will
forward
change
resistance.
as per your specifications. Done?
Yes, sir.
Is it fine? Okay. Okay, we will just see this for now. So we'll just do the simulation, then have a look at it, and have a look at this for now. You're asked to find what is the value of RT if the pulse width required is 450 microsecond upon giving a valid trigger signal, assuming CT to be this much. What is the expression? Is it what is the
It is
expression?
R1.
TPW is equal to RT CT ln of what is this? Is it VCC minus VTH by VCC? These are all been derived.
Yes, sir.
Okay.
So it's VCC by VCC minus
Okay, what I
VCC minus
actually want,
external.
okay, VCC minus, okay, VCC by VCC minus VTH. Okay, how you can easily remember is, suppose,
Yes, sir.
because I know that if VTH is equal to 1 by 3 VCC, what is the expression? Is TPW is equal to 1.1 RTCT? If VTH is
Yes,
equal
sir.
to, sorry, not one third, two third. If it is 2/3 of VCC, then pulse width is so and so. Correct?
Yes, sir.
Suppose if this is not connected, suppose if you connect a capacitor here. If you connect a capacitor, then what is V control or VTH?
It's 1.1 RTCT.
No. What is V control? Suppose instead of this, if I simply connect a capacitor, what is V control voltage or VTH? That is two.
VTH.
That is 2/3, no?
Look, 1 by 2 by yes, sir.
2/3 of VCC. So in
2 by
this RTCT ln of VCC minus VTH, if you substitute VTH is equal to 2/3 of VCC, will it come like, okay, RTCT ln of 3? Suppose if this VTH is equal to
yes, sir.
2/3 of VCC, will it become ln of 3? So natural log of 3 is actually 1.1 or 1.09 something. Then this is 1.1 RTC.
Yes, sir.
So this way, of course, you need to have this value to be 3. This value cannot be 3. Suppose if you write it VCC minus VTH by VCC. So the expression now is RT CT ln of VCC by VCC minus VTH. Am I correct? This is TPW.
Yes, sir.
Of course, this you can derive also. Now, suppose you have any confusion whether VCC minus VTH or VCC so and so, so then you can simply use this thumb rule and then you are supposed to get this ln of 3 when VTH is equal to 2/3 of VCC. Done? Okay, then we'll go
Yes, sir.
to the simulation part of it. We just okay, share content. Is it visible?
Yes, sir.
Okay. Just observe the things. Is it similar to your, of course, is it the bistable multimeter?
Yes, sir.
If you can carefully see, we have connected trigger and threshold, and that is the input, and output is pin number 3. And of course, we have connected reset and VCC to 5 volt, and the V control voltage is 3. Correct?
Yes, sir.
What is expected now from this bistable multimeter? And you can see the sine wave. If I just show you the description of sine wave, can you see how the sine wave is looking?
Yes, sir.
Can you see the amplitude is 2 volt, DC offset is 2.5, the frequency is 1 kilohertz. What is the maximum of this sine wave then?
Yes, sir. 4.5.
Minimum?
0.5.
Minimum means 0.5. So we shall run this. What is the expected threshold voltages? What is VTL, VTH here now? What is VTH, VTL
So
for this circuit?
VTH is 3 and VTL is 1.5.
Okay, we are looking at 3 and 1.5, correct?
Yes, sir.
Is that voltage of 3 and 1.5, will it be crossed by your sine wave? Let me just go back to, wait, just give me 1 minute time. Now, I have a waveform.
Yes,
Is
it
the
will be.
camera visible? camera content.
Yes, sir.
Okay, this is now 2.5. Over and above this, I'm applying the sine wave. Am I correct? Is this 4.5? Is
Yes, sir.
this 0.5? Correct? Am I there?
Yes, sir.
Am I looking at the threshold voltage of 3
Yes,
and
sir.
1.5 volt? Can you see the green line?
Yes, sir.
3 and 1.5. Now, what is the expected output voltage? Now, when it exceeds 3, what is the output? When it exceeds 3. When input voltage exceeds 3 volt, what is the output voltage?
So the output will be
Okay, let us
the
draw the
output will be
lines.
1.
Let us draw the lines wherever it is crossing, wherever it is going above 3 and going below 1. I'm not writing wherever it is crossing. I'm writing those transitions where the input is going above 3 and input is going below 1. Trying to understand? Write all those
Yes,
intersections
sir.
where input is going above 3 and below 1.5 volt. Why above 3 and below 1.5 volt? Because when the
So
input
because when
voltage
it crosses, it
exceeds,
will change
when the input voltage exceeds VTH, output goes to 0.
VTH and VTL. It will.
See now, suppose if it was at 1, it will go to 0.
Yes, sir.
If it is there at 0, it will go to 1. This is how it is going. This is 5 volt, sorry, in this case, okay, I have connected 5 volt, this will be 0. Correct? Let me go back to this and show you that. Will you run? Carefully observe, I have kept a frequency of 1 kilohertz. I am
Yes, sir.
simulating up to 5 milliseconds. How many cycles I'll see? How many cycles of waveform I can see? 1 kilohertz means time period for 1 cycle is 1
So
millisecond.
5.
I can see 5 cycles, correct? I will
Yes,
run it now.
so 5 cycles.
Okay, I will see the input, I will see the output also. Is this fine now? Okay, let me change the scale of this. Instead of 5, let me make it 6 so that it is visible. Instead of 0, let me make it -1. Is it more clear? Hello.
Yes, sir.
Shall I expand this and then try to see
Yes, sir.
what's happening? Here, I will just move on the input line. When the input is, see here, what is the input now? 2.9.
The 2.9.
What is the output? Because the input is now lesser than VTH. Am I correct?
Yes, sir.
So that's why output is high. See here, blue one output is high. Is blue visible? Or shall I change the
Yes,
color?
sir. Yes, it's visible.
Okay. Okay. Now, when the input voltage crosses 3, can you see it is when it is 3.06, what is the output? Is it going 0?
0.
And when the input goes below 1 volt, sorry, 1.5 volt, here when it is 1.49 something, 1.459, which is below 1.5, is the output going high?
Yes, sir. VCC.
This is going to VCC. So this is the output waveform. We can set, any doubt anybody here? So those who have any doubts, please unmute yourself and then speak to me. Input voltage when it crosses, when it exceeds 3 volt, output is going low. when the input voltage goes below VTL, output is going high. And I can change the x-axis. If I change the x-axis by input voltage, then I'll get the transfer characteristics. Shall we do that? What is an x-axis now?
Yes, sir.
It's time now.
Now x-axis is in. Yes, sir.
X-axis is time, quantity plotted is time. Let me just change this quantity to input voltage. So what is the name of the input voltage? It is this V of N002. I will type
N
that
double not
N002. What you are supposed to get? You are supposed to get the transfer characteristics.
the transfer characteristics.
I will show you that. Can you see now? These are transfer characteristics. Again, I'll change the scale so that it is properly visible. I'll make this 6, and then I'll make this -1. So that it plays. Is this fine now? Is this the same characteristics what we got yesterday? Can you see this is there? Of course, there are no arrow marks. Arrow marks we need to write it by ourselves. You can see when the input exceeds 3 volt, this is 3. More than 3, it is going 0. Less than 1.5, it is going. Anything less than 1.5, it is going high. Just say whether it's okay, or shall I just repeat this? Put in chat box. Put your response in chat box. Okay, shall I repeat this procedure of changing the x-axis settings, or did you people get the things? Come on, come on. Speak out in the chat box. I'm not getting any responses. Are you all there? I don't know how many of you are there with me. Okay, I have only 52.
Yes, sir.
Another 13 or 14 students are not there. I don't know what they're doing. Hello, just respond in the chat box. I said, okay, why none of you are responding? Are you all typing or what? Or is there any problem from my side in terms of network? I'm not getting any responses. Hello.
What is that green line?
What is that? Come again.
What is that green line?
What? Oh, green line is input. I can see this is input here. N002 is input, and sorry, on x and y axis, if you have the same quantity, will it be a slope of line 1? Will it be a line of slope 1? You take a graph, you plot same
Yes, sir.
quantity with same units
Yes,
on x and y axis. Will it be the line with a slope of 1? Hello. Input on
Yes,
x
sir.
axis, input on y axis. Because you can see this is y axis parameters, and this is x axis parameter. So can you see Vn002 and Vn002 both on x and y axis? Hello.
Yes, sir. They are same.
That's why there it's a straight line. It's like this. So I'll just show you in the. Suppose if you have some x, some vx is here also. So we used to write it in clipping clamping circuit. Now some dotted line. This is a reference. So this is like, okay, on x and y axis, it is the same parameter. It's a slope with line. It's a line with slope 1. Am I okay? Why none of you are not responding? Are you all there? Can somebody unmute and say, okay, I responded, because I'm not seeing any of your responses. Hello. Okay, I don't know okay, what to do, what not to say. Who is 25? 25. 25.
Yes,
For unmuting, how much time you take, is it? 25? Hello.
yes, sir. 25.
Did you respond in the chat box? Hello. Hello.
Yes, sir.
Did you respond in the chat box? Hello. Hey, come on. Who is 11?
Yes, sir. It's a network issue, sir.
Who is 11?
Yes,
Is it fine?
yes, sir.
Okay.
Yes, sir. Sir, am I audible?
You are audible. I don't know why I'm not getting the response of any of you. Can you people see? I don't know whether you people can able to see the chat box things. Don't know. Okay, fine. Suppose if I just change this to 2 volts, what will happen?
The threshold will change. So VTH will be 2 volt and VTL will be 1 volt. So when it exceeds VTH 2 volt, it will go to 0.
Shall you see this? So now it's happening at 3 volt. Now it will shift to 2 and 1. Correct?
Yes,
Shall we
it
run? This is that initial glitch. So what I'll do is let me not in order to just avoid this, what we can do is I'll just not plot saving data from point maybe after 1 millisecond. I will not see the first cycle. Let me just do this and then say, is it fine now? You know?
yes, sir.
Of course, you can change the scale so that you can see this slide properly. 6 and minus 1 minus 1. Is this fine now? You can see this is 2 and 1.
Yes.
Okay.
Yes, sir.
Fine. This bistable fine. Now, okay, let me just go back to this circuit and then let me just change some amplitudes or settings. Let me make this amplitude as 1 volt. And if I, okay, please observe this, the change that I made in the sine wave is, it's a 2.5 volt offset, amplitude is 1 with a frequency 1 kilohertz. Noted? Now I'm looking at what the output.
Yes, sir.
What may be the output? 2.5 volt offset, 1 volt amplitude. What is the expected output? Which we control as what? Which we control as 2 volt. What is the
2 volt.
expected output?
So the site will be same only.
Okay,
The output will be same. Just
output will be same. Let us see
like,
what is output. Output is not same. Output is 0. See the red line? Is the red line down? Okay, let me just change the scale.
yes, sir.
Let me change this scale to 5 and minus 1. Oh, can somebody say why the output is like this for 2 marks in Q1? Why the output is at 0 volt? Anybody? It's a sine wave. See, okay, let me just also.
It's not crossing 2/3 limit, right, sir?
It's not crossing.
2/3 of VCC value.
It is crossing. That's why output is 0. What is 2/3 of VCC?
But it should come back to 1/3 of VCC, below 1/3 VCC, so that it can reach high, right?
It's not 1/3 VCC in this case now. Please have a look at the circuit. What is VTL, VTS now?
By 2.
See the input waveform. Input
2
waveform
and
is,
1, sir.
input waveform is starting from 2.5. It will go up to 3.5. It will go till
5.
what? 1.5. Correct?
1.5, sir.
Suppose
VTL is 1. It is not crossing VTL value.
it's not going below VTL. So that's why.
VTL.
No, VTL.
Yes, sir. VTL is 1. It is not coming below VTL.
Correct. So this is 2.5. This is going up to 3.5. This is going down till up to 1.5. Your VTL is here. Am I correct? This is 1 volt. Since it is not going below this VTL, so if it doesn't go below VTL, does the output can go to high?
No, sir.
For output to go high, for V0 to be equal to VCC, what is V in should be less than 1/3 of VCC, or this is in general, or it should be less than VTL. Am I correct?
Yes, sir.
Since it is not going, this is VTL, this is V in. Since it is not going below that, output is at so and so. Am I correct?
Only in 0 state. Yes, sir.
Can somebody tell me how do I make the output voltage only at high? With what values I can make it only high output? Can somebody tell me what is
changing the DC offset?
how much?
Changing DC offset.
How much shall I keep it?
0.5.
0.5. Then what are the peaks?
Yes, sir.
What are the peaks?
1.5 and 1.5 is VTH. It will go up to 1.5.
No, it's not VTH. VTH is 2 only. VTH
No, sir.
depends on this one now.
In the peak, it will go till 1.5.
It will go up to 1.5 and it will go down till? Go down till?
Not
minus 0.5.
Yes, sir.
Minus 0.5, correct? Then output is not going below, output is not going above 2 volt. So the output is, since the input is not going above 2 volt, output is always at VCC.
Yes, sir.
Since the input is not going above VTH, output cannot change to 0 volt. It will be always at VCC. You should see that. See that? Is it there at VCC all the time?
Yes, sir.
See that? Always VCC. Even though you applied a trigger signal or the input waveform, since it is not crossing VTH, output is not going down. So it is stable there. It is stable there. If it has to come to other state, you have to exceed VTH. If it has to go to one more state, it has to go below VTL. Done?
Sir.
Is bistable done? 100% pakka to all of you?
I got it.
Anybody any problem with bistable multivibrator? Okay, then we shall just move on to monostable, try to understand some more concepts of that. Okay, this I will close. Okay, I will say can somebody tell me what is the pulse width of this? RTCT is given and VTH is also given here.
Frequency.
All of you calculate what is TPW, first fit of the monoshot. Is it a monoshot circuit first? First of all, try to understand the circuit.
916.29 microseconds.
Come again. TPW how much? Okay, let me just show you the expression. Is the expression this one? RTCT ln of VCC by VCC minus VTH. Hello. Hello. Hello.
Yes.
Yes, sir. 916 microseconds.
916 microsecond. Is the equation fine? RTCT ln of VCC. Okay, now VCC, what is the value of VC that you have taken here for this circuit?
5 volt.
5. So it is 5 by 5 minus 3 ln of that and RTCT. Is it 916 microsecond to all of you?
Yes, sir.
Yes, sir.
Okay, that is done. Let us, and it is very important that we need to properly give this pulse. Just have a look at the specification of the pulse. Can you write a pulse waveform for this? Can you write the waveform for this specifications? It says that initially it is 0, on it is 5 volt, there is a delay of 1 nanosecond, and the rise time is 1 nano, fall time is 1 nano, on time is 10 millisecond, total period is 10.1 millisecond. I want all of you to write the waveform for this, for these specifications. So it is 5 volt and it is then 0 volt and on time is 10 millisecond, total time is 10.1 millisecond. And what will be the off time?
.1 milliseconds, sir.
Correct. So this will be
0.1 milliseconds.
Millisecond. This will be 0.1 millisecond. Is it something like this? Let me just share. It will be something like this. This is 10 millisecond. 1 and it is off for hardly 0.1 millisecond. Is this a valid trigger signal for our circuit? What do you mean by valid trigger signal? The off time should be less than
a particular threshold value.
the off time should be okay. One of the specification is off time should be less than T per switch and the low value should be lesser than VTL. Correct? Low value, whatever the low value you are getting, low value should be lesser than VTL. Getting the point? Hello.
Yes, sir.
Okay, let me just go back here and then save this and then run. Shall I see what is the input waveform? Shall I see what is the output waveform? Shall I see the capacitor voltage? I'm seeing all of them. What is control voltage now?
3 volt.
Perfect. You know, let me just concentrate on this. Can you see this is your, okay, let me just change the scale here to, is this fine? Can somebody explain what is this happening?
Yes.
Can you see the trigger signal is going below VTL, which is 1.5 volt. Can you see the output is going high? How long it is staying in high
Yes, sir.
condition?
So for
As per our RTCT. As per
10
RTCT,
milliseconds.
what is the value of time? That time is supposed to be 916 microseconds. Let us see what is the time. Is the difference almost close to it? Can you see it's almost there, 926? Can you see here?
Yes.
Hello. Okay. One more important thing is that capacitor can charge up to what voltage? Can you see it's going up to
Up to 3
3
volt.
volts? VTL, sorry, VTH.
Yes.
There is no question of VTL here.
Yes, sir. Up to 3 volt.
VTL is now related to your trigger voltage. So input should be, sorry, trigger should be less than VTL, and the capacitor voltage exceeds VTH, output goes to 0. Correct? Hello.
Yes, sir.
What I want to say is, so is this a valid trigger signal now? Because the pulse width is lesser than the, sorry, the off time is lesser than the pulse width, and this is going below VTL. What we'll do, we will actually make the waveform to go like this. Let me just slightly modify the input signal to go like this. So I will not allow it to go down below VTL. How do I do that?
Sorry.
I will change this initial voltage is there now. Okay, let me just go back here to this and show you. V initial, I'll make it around 2 volt. What do I change? See here. If you carefully see, can you see there is a trigger signal coming here now also? Hello.
Yes, but it is not going below
It's not going, since it is
VTL.
not going below 1.5 volt. Can you see the output voltage is always 0? Correct?
Yes, sir.
And capacitor is not at all charging. Why capacitor
Yes,
is
sir.
not charging is because that it is that the transistor is always on, it is keep on discharging. Correct?
Yes, sir.
So one of the important condition for trigger signal is trigger signal should always go below VTL. Correct?
Yes, sir.
So what is the voltage that you have here now? Is it almost 2 volt here?
Yes, sir. It should touch 1.5 volt.
This is 2 now. This is actually, is it 2 volt? Because it is now, initially is 2 means, okay, minimum voltage is 2. Suppose if I make this equal to 4.5, will it work? Now for this 4.5 trigger volt, sorry, the control voltage, is this trigger a valid one?
Yes, sir. It will work.
Why? How it will work? How it will work?
So because like VTL is 2.2 something, and we are applying the trigger voltage, which is less than 2.4.
Perfect. The
2 volt.
VTH is 4.5, then VTL is 4.25, sorry, 2.25, half of that. Is it not?
Yes, sir.
VTL is half of 4.5, which is 2.25. The trigger signal is going till 2 volts. So 2 is lesser than 2.25. So you will get a, then this will become valid trigger signal for this control voltage. You will get the proper waveform. Are you now getting the waveform? Interestingly, now this pulse width will not be 960
Yes, sir.
millisecond. It will be different because you have changed the VTH value. Am I correct? So what is the moral of the story? What is the summary?
Yes, sir.
What is the summary?
So it should go minimum VTL. The trigger should go below VTL to get a trigger signal.
For a valid trigger signal in case of 555 timer, the V trigger should be always lesser than VTL. Should be always lesser than VTL for a valid trigger signal. Done? Just put it in block.
Yes.
Just put it in a box, all of you. That's why in one of my assignment question, I asked, what do you mean by valid trigger signal for a 555 timer? One of the things is that valid trigger signal for a 555 timer is one whose low value should be lesser than VTL of that particular circuit. That? Okay, let us just again go back to same circuit. Same circuit. Let me again make it equal to 3. Let me again make it equal to 3. Let me make this equal to 0 and let me make this equal to 0 only. So let me give a valid trigger signal, which is 0. Is it valid now? It's perfectly valid. Am I correct?
Yes, sir.
Were we getting 916 microsecond earlier? We were getting. Correct?
Yes, sir.
So what I'll do, I will slightly make
Yes.
this change. So what I'll do is, let me see. What I'll make it 15 millisecond. What is this? What does this? In what way this will affect your waveform? Can you tell me what is on time, off time?
So
The trigger, the
What
T
is-
off is increased by is 5 milliseconds now.
Now, is T on is equal to 10 millisecond, T off is equal to 5 millisecond? Am I correct?
Yes, sir.
So,
Yes, sir. The trigger is for around 5 milliseconds.
trigger is that is input signal. Yeah, the trigger signal is less than VTL for 5 millisecond. Correct? Let us see what happens. Okay, what is the expected pulse width now? What is the expected pulse width as per this? It should be 916 microsecond. Correct? Shall we run it now? Just let me change these amplitudes. Let me make it equal to 6 here. Let me make this equal to this one equal to 6, and let me remove this function. See what's happening. Carefully observe this. What was the expected off time? Sorry, what was the expected pulse width?
So
Expected pulse width?
916 microsecond.
916 microsecond. Shall we measure that? Interestingly, can you see the capacitor voltage
Yes, sir.
is not stopping at VTH, it's going till VCC. Am I correct? See the
Yes, sir.
capacitor voltage, is it almost reaching 5 volt? In the previous case, was the capacitor voltage reaching only
Yes,
up to
sir.
VTH? Interestingly, you can see, is this output going high is for the entire off period? As long as this is off, let me just make this also -1 here. As long as this is 0, as long as this is 0, is your output is high? Hello.
Yes, sir.
So that means to say,
Yes, sir.
is your RTCT deciding the pulse width for this trigger signal? What is the pulse width here now?
Yes, sir.
What is the pulse width here?
Uh,
Pulse width here is equal
so
to clock time.
916 microseconds.
No. See the pulse width is, suppose if I just measure it, it's exactly 5 milliseconds. You see there? Is it 5 milli? But what was your expectation? Your expectation was
We
916
expected
microseconds.
916 microseconds.
You expected 916 microsecond pulse width for the output of your mono shot, but you are getting a 5 millisecond output. It is purely because you are not applying a proper trigger signal. Let me just
Yes,
come
sir.
back to that and then show you in my here. So this is the trigger signal what I have given. This is for 5 millisecond. This is for 10 millisecond. Correct? Is this actually going to V trigger here? Correct? Is this V trigger is actually going to a comparator point where it is this one? Correct? Hello? Can you see?
Yes, sir.
Since this voltage is lesser than VTL, so what will be the output there? What will be this? Will it be 1?
Yes, one
That is 1.
volt VCC.
Meaning,
Yes, sir.
as long as trigger is lesser than VTL, output is always high.
Yes.
Note this point. As long as trigger is low, output is always high. Always high. So what is a valid trigger signal now? I have to generate a trigger signal such that it should go below VTL for a fraction of time. So my trigger signal should be something like this. Even though you have an input waveform of something like this, I have to generate a spike out of this. So I have to generate a spike like this.